the last video, we are discussing about label encoding and ordinal encoding. Now let's go through the code. Okay. So here we are loading data encoding.csv. It is a sample data file which I have created, in which there are three columns. First one is our output column, and second one is the class column, and the third one is the grade column. And in the class column, as we discussed, there is rich, poor, and middle class. And similarly, in grade column, we're having four different values that are A, B, C, and T. Okay, so this is our data set. And if you guys remember, on class and grade, we wanted to use ordinal encoder, right? That's because we wanted to specify the order in which we think. So if we think of grade, we wanted to specify order in such a way that A comes first, and then B, and then C, and then T. And similarly, in the case of class, we wanted to specify first rich, and then middle class, and then poor, or reverse. Okay. So let's see how to do that with the help of code. So in sklearn.preprocessing, there is a function called as ordinal encoder. We can directly use that, and we can mention categories. In these categories, we need to mention the order in which we wanted to assign the values, like rich, middle, and poor for this column, class column, and similarly A, B, C, and D for the grade column. And after that, we need to fit. On fitting, it will just do some mapping like rich to 0, middle to 1, and poor to 2, and similarly this to 0, this to 1, this to 2, and this to 3. And actually, it will not change in case of it. It will just do the mappings. Whereas while doing transform, it will make the changes. So here, if I observe, if I print it, it is looking the same because it is not changing yet. Now let's do the transform and see the same. So here, if you observe, on doing transform, it will be changing the values respectively, and it will be returning some numpy array, and that we are storing it in the data frame again. Okay. Now if you observe, the values got changed. Let's see whether these values are matching with the like order that we have specified or not. We have specified rich first, and rich is assigned with 0, and then we have poor, and poor is the third one that need to be given 2, and then middle is given 1. So these are correct mappings. Now let's see with the ADBC. So first for our ADBC, that means we should get 0, 3, 1, and 2. Let's see is the order correct or not. 0, 3, 1, and 2. Yeah. So the encodings are done correctly. So like that, we can use this ordinal encoder. And similarly, if you wanted to check in the way which it has assigned, we can simply use this oe.categories underscore. It will give those respective class values or category values, categorical values. And you can apply inverse transform as well. If you provide the same columns that we have given in fit or in transform, then it will just do the inverse transform and it will obtain the original values. So this is the original column values that we are having and that we obtained through the ordinal encoder that we are having. Okay. And like in case of output column, like we can simply use this label encoder. Basically, this label encoder can be mostly used on output columns, or let's say on some input column, there are a lot many values within a feature. Like here we are having three values, right? Rich, poor, and middle. Like that, we are having some 10,000 different values. In such case, it's better to go for label encoder because like in ordinal encoder, we can't specify them in some specific order, right? So, or if we are going with the output column, then we can simply use this label encoder. We can use simply a scalar.fit person. We can take this label encoder, and then we can fit. And after fitting, we can transform. And on transforming, our output will change in the respective manner. So in label encoder, what it will do, it will just randomly assign the values. And if you observe the classes, it has assigned in this specific order. It is not necessarily this order only. It can assign in any order. And similarly, we can do inverse transform here as well, and we can obtain the original character values that we have in our dataset previously. So this is about label and ordinal encoding. And now let's discuss one small point. So let's say there is a feature that is city. So city is the feature, and in this city there is Hyderabad, and there is Delhi, and there is Noida, and there is Mumbai, and there is Bangalore. Let's say these are all the different values that we are having. And if we are using label encoder, then we'll assign some random values that is 0, 1, 2, 3, 4. Let's say these are the random values that it got assigned. So, but the problem with these random assignments is like we don't want it to give more importance to Bangalore. It is assigned with higher value. So this is more important than Hyderabad. Or if we can see, like we are specifying in some order, right? 0, 1, 2, 3. That means there is some relation in these things. Similarly, if you use ordinal encoder also, there also some specific order will be there. So here we are trying to show some order to the model by assigning these values like this. But in general, we wanted to tell the model that these are all independent and these are all equally important. In order to tell that, what encoding technique we'll be using? We'll be using something called as one-hot encoding. Okay. So this we'll be discussing in the next video. Okay. That's it for this video. If you guys have any doubts, you can comment on the comment section. Thank you.